Hello and welcome to part 3 in our series on the visual effects of the Infiltrator tech demo. Today we're going to take a look at the fireball effect that was seen about halfway through that demonstration, and joining me is senior visual effects artist Francois Antoine. Hey Francois.
Hey Zach, how are you?
Doing well. So why don't you start by telling us a little bit about yourself?
Sure, so before coming to Epic, I worked in film visual effects for 10 years. And I'm excited about this demo today because we're going to be showing an explosion which uses some of the same techniques that we use in film visual effects.
So can you maybe give us a kind of an overview of what's so special about this effect?
Well, we had to create this explosion with a new technique called volume texture. And it's basically a texture that's three-dimensional. And that in combination with GPU particles allowed us to create what we call our volume explosion. Traditionally, sprite-based explosions don't have that cohesive feel. But the volume explosion kind of overcomes those limitations and gives the impression that it's really rolling through the geometry and expanding. So the first step was to create the data for the volume explosion. And for that, I went into 3D Studio Max and used the FumeFX plugin to generate a 3D fluid simulation. And you can see that here we imported the geometry from Unreal Engine and using FBX. It actually saves the placement of all the geometry and also allows you to import camera with the camera angle and the different lens settings.
Which I imagine would be useful here, where you kind of need to wrap a fluid simulation around that.
Yeah, absolutely. Actually, having the camera allows you to really customize and animate to the camera, which can be a big time saver, so you don't waste time animating things that won't be seen on the camera. Once we have the explosion going, what I did is that I rendered 10 cross-sections of the fluid simulation from a top-down point of view. And you can see that each of these cross-sections is represented by the volume between each of these planes. So these are now rendered out, and one of the cross-sections looks just like this. And you could actually see inside the explosion right there, because this is a middle cross-section. All right, so once I had all these cross-sections rendered out, I brought them together inside After Effects. And over here you can see on the left here, I have all 10 cross-sections stacked on top of each other. This was just a way to test to make sure that there were no rendering artifacts or shadows from one layer into another. And it was to make sure everything was properly sorted before bringing that information into Unreal Engine. So now we're going to import each of these slices as a sub-UV texture. So this is one of the bottommost layers. You can see the cross-section for each of the frames of the render.
And I imagine this would be one of the lower slices.
That's exactly right. As the explosion moves up, it just leaves behind smoke. So what we could do is look at one of the higher level fireball slices. And you can see here that you have nothing in the beginning because the fireball hasn't reached that area of the fluid simulation.
Right.
And then the top cross-section is right here. So the next step is to recreate the information between each of these slices. So here we are inside the material that we wrote. You can see here there's a node called the volume texture sample, and this is where we create the 3D volume texture. It is also a function, as you can see, it's highlighted in blue. A function is basically a network of nodes that can be reused very easily, kind of like a snippet of code.
And this was created by artists. You didn't have to bring in a coder to write this.
That's right, yes. And that's where the power of Unreal is that we can actually prototype these kinds of features using artist tools. So you could see right here we have more functions, and each of these functions reference one of the slices that we rendered out earlier and brought into Unreal Engine. You also see there's also extra parameters here that artists can set, which is like the XY size of the volume and the slicing between the space between each slices.
So a little bit of further customization if you need it later.
Yes, and because these are parameters, then they will be exposed to the material instance, which we'll plug in later for the explosion.
Very nice. Okay, so you've got your material at this point. What's the next step?
So the next step is to actually be able to display that volume texture. Typically, a way to display the volume texture is to ray trace it, but that is very expensive, so we didn't want to use that approach. So instead, what we're using is a point cloud of particles, and what's going to happen is that each of these particles is going to look up a certain point in space of the volume texture and display those color values.
So I noticed the particles aren't moving. We're looking at this in wireframe right now. So I guess each one of these is kind of like a static monitor.
That's exactly right, yeah. The motion is not in the particles, it is in the texture that is actually animated. So we basically just need a lot of tiny little billboards that will sample that texture and display it. So they're not moving for that reason. So right here, we have about 500 GPU particles, which is our GPU particle system. That's the right amount when we're kind of far from the camera, but here, because we're looking at the explosion pretty closely, I'm going to increase that count just for the sake of visualizing the explosion up close. So 2,000 particles is still very cheap by GPU standards. So now we can see the explosion happening, and if we go to the top view, which is where our camera is for the shot.
Oh, that is amazing. You can actually feel it like creeping up at the camera.
Yes, and that's exactly the feeling we wanted. That's something we don't traditionally get with regular 2D sprite explosions because they don't have that coherence between each other and they don't have this kind of growing volume.
Very nice.
So because it's made of slices, if you switch to the side view, you'll be able to see what our material is doing. You can see each of the 10 slices in effect here, and you can see our material is creating interpolated data between each of these slices. So in effect, we're recreating the explosion accurately from the top down, but using more efficient interpolated data where we don't need the detail.
Right, so it's not going to be perfect from all angles, but you've still got a wide range of visible areas and a lot of motion and depth in the overall effect.
Exactly. If we needed to see this explosion from the side, we probably would have increased the quality, the number of slices, or used a different technique altogether. But for what we need, which is some subtle parallax and that rolling motion, this is just the right fit for that shot.
Awesome.
So you can see here on the output of our volume texture node, we're plugging into the black body node. What's special about the black body node is that it takes in a temperature in Kelvin and returns a color. And in effect, this allows us to color explosion in a more realistic way.
No more, I guess, having to fight and figure out what the best color for fire is.
Yes, that's right.
Awesome.
Okay, so the next step is to get it into the cinematic so we could see it. So I created a number of tracks in the cinematic tool, which is Matinee. You can see I'm triggering the explosion using the toggle track for the explosion.
And that's just going to turn on the explosion and that's all?
That's correct. That just triggers the explosion and has it running. But because we want it to sit better in the environment, I create also a track with lights. And this is called the explosion light, and that just creates light right here. And it kind of blows out the environment, so you really get the feeling that there's an explosion going off. Mm-hmm. And on top of that, you can see there's a layer of distortion right there. And the distortion is just a sheet that has a distortion material applied to it that sits on top of the explosion and moves up with it. So as it gets closer to the camera, you start getting that feeling of heat and heat shimmer. So if we run through the cinematic, we can see the completed effect.
Tell me, how did Unreal Engine 4 enable you to make this effect? Is this something you could have done previously?
It would have been hard to do previously because we're using custom material functions in the material expression editor. And on top of that, we need to use GPU particles.
Well, Francois, thank you very much for your time, and thank you for joining us. We will catch you on the next Inside Unreal.